Hello and welcome back. So these are the breadboards where I'm assembling the transfer register. So this lower half is just a test circuit, provides a couple of inputs and some control lines. And then this is the lower half of the transfer register, or at least the bit that does the loading. So I've got the two control lines which will trigger it to load its data from one of two buses. So what I'd like to do today is flesh out this lower half of the register and get it so it can assert data back to any one of the three buses that it will be connected to. Right, so I'll be using these 74LS541 chips, and I think this is going to be easiest if I line up the inputs with the outputs here. Okay, I've also recovered a bunch of these green wires, so I'm going to space these out and line the chips up with the wires I've already got cut. Power and ground on all of them. And we've got output enables both here and here. Now we only need one output enable line, which is going to be our assert control. So we need to bring these ones low. Put that ground line in the wrong place, but that works. Okay, so now I need the data outputs into the nearest one. So this will be the main bus, the transfer bus and the address bus. In these two cases it's the lower 8 bits. And to bring all of these connections across. If anyone knows where you can get breadboards with more than 5 wires on each side, that would be quite useful for these. Okay, so this is now the main bus. These are the lower bits of the transfer bus and the lower 8 bits of the address bus. So these wires should really come from over there. And then the same for these lines. And these are our asserts. They are all active low. So I'm going to bring them high. Not a lot else to test here apart from confirming we haven't broken anything. I always like to put the red line into the least significant bit. Okay, looks like we've broken something. That's not right. That one looks correct. That doesn't. Not sure why we got a bit of instability on that line. Okay, I have picked up the wrong chip. This is a 574. That explains why that's not behaving. I do keep these 541s and 574s next to each other, but that was a bit of a bad mistake. Okay, we're still seeing a little bit of erraticism on that top line. There should be a slightly loose connection here. A couple more caps in. Okay, I'm going to try something. So this is the 74LS08 quad AND gate. So I'm just using one AND gate here. I'm going to bring a second one into play. Okay, let's give that a try, and if it works, I'm going to have to spend some time explaining why it works. Okay, so that is working completely stably now, which is what we wanted. Right, so the next thing I want to do is we'll put a third cable in there, and these 3 buses and these 3 control lines and these 2 control lines can then get wired into the main build, and we can give this thing a bit of a test. But I think I need to explain a little bit about what I just did here. To explain that, I think we need to go back to the design. Okay, so this is the design for the dual port register we've been working to. This is very close to what we've built on those 2 breadboards. In fact, let's update it to match it. We've got the pair of multiplexers, the latch, and on this we've got 2 line drivers driving 2 buses. So this would be the main bus, and this would be the lower half of the transfer bus. And then we've added an additional line driver off to the lower half of the address bus. So this is the low half of the transfer register. And we started to see some problems, and then I made a small change. So I'd like to explain what that was. Now, as a reminder, we have the 2 load lines, which are the 2 buttons on the left of the test board. They both go into this AND gate, which triggers the load on the latch. So this latch chip will load the values on these inputs on the rising edge. So if either of the load lines go low, this one will go low, and then when it returns to high, the latch loads. Then to decide which of the inputs we're going to take, we feed one of those lines into the input select on the multiplexer chips. So when it goes low here, this is making the choice, or if this one goes low, this line hasn't changed and stays high, and we get the right set of outputs on these brown lines. But there's a small problem there. Now, the latch chip here will load on the rising edge. So the line values here at the point when this line goes high should get loaded, but not everything happens instantly. When this load line changes, this input select changes, but this AND gate has a small amount of time associated with it. Now if I check the data sheet on the particular AND gate that we use, that's 8 nanoseconds. That's not a very long period of time, but the moment this changes, these lines are going to start to change. And this mostly works because the propagation time on these multiplexer chips is more than 8 nanoseconds, but the outputs aren't really guaranteed the moment we change the input. So those lines are going to start to change. The signal gets delayed by 8 nanoseconds through the AND gate, and then the loads signal hits the latch chip. So what I did was I added a source of delay on this input select, and what I had available to me was one of the spare AND gates on that chip. This didn't have to be an AND gate, it could have been one of many different types of gate as a way of delaying this signal, but what I had right next to the line where I needed it was one of the spare AND gates on the chip where this one came from. So I wired 2 inputs together, so the output will be the same as the input, and this AND gate will provide just as much delay as this AND gate, and so then that fixed the circuit and it started working reliably. Now we only saw the slightest issue, and only when we added the extra line drivers, but we were obviously right on the edge, so this made it nice and stable again. It's a very simple change, but this kind of error is one that we really do need to watch out for. Now, if you go back to the video where I was troubleshooting the odd increment behavior on the program counter, I actually said at the start of that I had a couple of theories about what might be going on, and it turned out that my first theory panned out and that's solved the problem. But the theory I didn't mention was actually very similar to this. And what that related to was the clock line going into the 3 to 8 line decoder chips was very slightly in advance of the selection signals going in. And so I've effectively solved that issue with the bus control circuit, because the clock line there is going through two inverters, which nicely solves the fan out issue. So I wasn't too worried about it there, because I knew the planned circuit for the bus control would even out that problem, and so it should never manifest for us. But I was worried about it at the time, and I was kind of aware of the possibility here. So it's kind of interesting to actually see the problem that I was looking at all the way back then actually manifest to a degree. Okay, so the last thing I want to do today is fix up the schematic that we've been putting together. So here is our main bus and our two 16-bit buses that we're driving. We've got the AND gates down here, which are bringing the TL and TX and the TH and TX lines together to create the load for the low and the high pairs of multiplexer chips. And we've got two spare AND gates on here. Right, so the circuit we've been looking at is the low half, so that's this section here. And so we don't want to feed TL load directly in there. We want to feed it into the AND gate. So we need a couple of new signals. So we call that select low and select high. Do the same for the upper half as well. This is of course why it's good to build it on the breadboard and give it a test before we have a PCB made. Okay, so let's write some test code and do the updates we need to support the transfer register. Okay, I did put stub entries in for TL and TH for the 8-bit loads. I need to flesh out moving between TL and TH and the general purpose registers. I'll do some renumbering here so I can put them in with the other 8-bit operations. Okay, so we need to write some test code that uses that. Actually, I'm going to add some loads for these ones as well. Then we can test that the address bus assert works. Rid of all this old test code. So let's try moving. If we do a direct load of 64, stick a NOP in there so we can keep an eye on everything. Move SI, TX. Let's copy both of those over. Actually, when we implemented the bus control PCB, we never tested the increments for SI and DI. Everything else works, so let's kind of assume that's going to work, but let's test it now. So we're changing the lower 8 bits of TX. So that's clearing B, C and D. We stick 64 into A, we copy that into TL, then we move that into SI and DI. We increment SI 3 times, and then we move it back. So B should be A plus 3 at the end of that. Test that address bus as well. Okay, that should be all of the new functionality tested. It's a 21-byte program. So now we've got to update the control build for the new instructions we've generated. Okay, so we've actually got a TX register now. So we can take those temporary ones out. Add the assert entries. Oh, Obviously all of the TH references here are redundant because we've only got the lower 8 bits, but we may as well do this all at once. So we've got the 16-bit moves for TX, but we do need to add the 8-bit moves for TL and TH. Okay, so I'm going to pull all 5 ROM chips out of the build and get that all set up, and then we'll give it a test. Okay, so I've programmed all the ROMs. Don't need this bottom board anymore. This is the main bus that goes over to the ALU. I need to reroute this. So we can plug that main bus connection in there. Transfer bus can go in here. And it occurs to me we don't have a convenient place to put the address bus. I think we can just ignore that for now. That circuit is pretty much a copy of what we already do, so we can be pretty sure that will work. It's this functionality we want to test. Okay, so assert to main bus for TL goes there. Assert to transfer. Going to need some longer wires for these load lines. TL load. TX load. Okay, can we get power from over here somewhere? Okay, I think that's everything. Okay, so the first instruction was move A, 64. So here it comes. So there's our 64 in the constant register, and then there's our 64 in A. Then we've just got the sequence of 3 exclusive ORs, which are just going to zero these 3 registers. So that's started, so this one will load a 0 next. Then we've got a move TL, A, so if everything is working we should see the 64 come down to here. Yeah, so that will be this. That hasn't worked. The main bus has the right value on it. It's literally, the line hasn't loaded. That implies that we're not generating the correct signals down here. Okay, failed at the first hurdle here. Yeah, look at that. That's wrong. The constant register on the bus control circuit we put at address 5. TL and TH was 6 and 7. So on the load, that also needs to be 6 and 7. I'm going to fill in the load constant. We're not using it, but I think if we put the entry in here, it will avoid us making a mistake like that again. Okay, so program ROM doesn't need to change, but this is just main bus control, so that is going to be pipeline stage 2A. load A,64, 3 zeros, and then TL from A. That's cool. So then we followed that by 2 NOPs. And then we've got to move SI, TX. So it's going to test the assert of TX. This is SI. Now we've got no idea what's going to happen to the top 8 bits. We've kind of left them floating. But the bottom 8 bits of SI should receive this 64. Nice. And then the same into TX. Sorry, same into DI. Okay, so yeah, we got garbage in the top half. We were lucky with SI. So then we increment SI 3 times. Now, we haven't actually tested that increment functionality in the bus control, which is why I included it, because the increments for PC and RA are separate than the increments for these. So there's a chip in here we've not actually checked. Well, that worked. 2 more NOPs. And then this is a move TX, SI. So that will move this back into the TL we've got here. Outstanding. And then we added the move C, the address of TX. And we haven't hooked in the address register, so we're going to get garbage in here. Oh, sorry, we haven't hooked in the address bus output, so we're going to get garbage. But yeah, I'm not too worried about that. So then we move B, TL. So that should copy this into there. Yeah, that all worked. Excellent. Okay, well, there's another piece of functionality I want to add to this, and then we'll finish off the PCB and the schematic, get that made, and that will fit nicely in there. I think I may have to seriously consider moving forward with making a PCB out of the ALU over here, because I really am getting a bit cramped on the desk at the moment. And if I move the camera any further back, you're not going to be able to see anything. The pipeline is still under construction, whereas this is pretty much final now. I think we should test getting the flags back into the core, because then we can be sure that works and move on to PCB. But this is great. It works. And I'm very happy with that. I hope you found it interesting. Thanks for watching. Goodbye.